Hello there and welcome to the series of videos going through the content of A-Level Maths. Here we're looking at integrating functions that look like f dash of x over f of x. That's the derivative of the function over the original function, so we can answer questions from exercise 11D. Now, in the differentiation chapter we saw that if we were to differentiate ln, then we get 1 over x. And there are a lot of functions that relate to fractions that if you were to integrate it, you would get back to something relating to ln of x. Now what we also see as well in the differentiation section is that if we were to differentiate ln of f of x, so that's ln of some function, maybe ln of x squared, ln of sine x, something like that, then if we were to differentiate that, then we get a general answer of dy by dx equals f dash of x over f of x. So that's to say that if we were to integrate f dash of x over f of x, then we would get ln f of x. So if you've ever got a question where you're trying to integrate something and you've got a fraction like this, then my advice would be to first have a look at whether you can differentiate the bottom to get it to the top, or near enough to the top. Maybe it might be a multiple of the top, and then there is going to be some link back to the answer being ln of f of x. So it's generally ln of whatever you've got on the bottom here. Okay, let's have a look at some questions to see how this works. The first question we're going to have is the integral of 2x over x squared plus 1. Now it's a fraction. The first thing I'm going to do when I try to integrate fractions is to try and spot what will happen if I differentiate the bottom. If I differentiate the bottom, I'm going to get 2x. 2x does appear on the top. So therefore I can use the ln rule straight away. So in this case here, if we were to spot that if we were to differentiate ln of x squared plus 1, then we would get the answer of 2x over x squared plus 1. So in this case here, the answer is just going to be ln of the denominator. If you can spot that the bottom will differentiate to the top, the answer is ln of the bottom plus c, all in modulus brackets. So we get this one here. In this case here, we have cos x over 3 plus 2 sine x. Now in this case here, if we were to differentiate the bottom, we would get 2 cos 2x. So we don't want a 2, we would like ideally a 2 to be in this position here, and then that will perfectly differentiate the bottom to get the top. But that wasn't the question. The question was just cos x. So to balance this out, what we do is we put a half at the front so that then the bottom does perfectly differentiate to the top, but the question's been balanced out by an inverse scale factor at the front. So in this case here, the answer to this question is going to be a half ln of the denominator. So it's always ln of the denominator if you can spot that the bottom differentiates to the top. Okay, so your turn to have a go at these questions here then. Pause the video and try these out. Right, okay then, so in the first question here, if we look at this question here and we spot we've got a fraction. Now when we've got a fraction, we try to differentiate the bottom to get it to equal the top. Now in this case here, ideally we'd have a 3 on the top, because 3x plus 2 differentiates to 3. So to balance this out, I need to put a 3 on the outside, so then these 3's cancel out, but there should be a 5 on the top. So I'm going to put a 5 on the outside there as well. And then perfectly we've reorganised the question, so we've got the perfect numerator on the top and the scale factor on the outside that will make the question match up and work. So in this case here, the answer to this question is going to be 5/3 ln of the denominator, so ln 3x plus 2 plus c. In the next question here, the bottom will differentiate to minus 3x. So in this case here, I would ideally like minus 3 on the top, so it would differentiate to minus 3. And in order to balance this out, I need a minus over 3 at the front, and then the 4 is actually in the question what we'd like on the top, so we'd need the 4 at the front there. So in this question here, the answer is going to be minus 4/3 ln of the denominator 1 minus 3x plus c. For the next question, we spot here that the integral of this the differential of the bottom here is going to be 2x. So we would like 2x to be on the top. Now, good, we've got the x's on the top happening, which is great. Now we'd ideally like a 5 at the front. So 5 will have to go here. We'll have to balance out the 2 that we've created by dividing it at the front. So in this case, the answer to this question here is 5/2 ln x squared plus 3 plus c. Now tan, I wonder how you did tan. Hopefully you rearranged tan into sine over cos. Now in this case here, if we differentiate, we've now got a fraction, so we can use this ln rule. If we differentiate the bottom, we get a minus sign. So in actual fact, a minus symbol needs to go at the front. But it is positive tan, our actual question, so we need the minus sign to go at the front to actually sort this out and balance it out to make it positive in total. So in this case here, the bottom now does differentiate to the top, so it's going to be ln cos x plus c minus. It's going to be a negative. And what some people do, and what they suggest you do in the formula booklet, is they incorporate the minus in as a power. And if you've got cos to the minus 1x, that's not inverse cos actually, that's the whole cos function being to the negative 1 power. This will give you 1 over cos, which will give you ln sec x plus c. So there we are, that's how we do these sorts of questions here. Have a go at some of the questions from page 302, exercise 11D, and try and have a go at the ones where you spot that they're fractions, so you can try and evaluate whether does it work with if I differentiate the bottom, do I get the top? Thanks very much for watching.